when we connect n number of cells of different EMF and different internal resistance. So we need to find out the cells in series, what is the total current. Suppose there are n number 1, 2, 3, 4 and n number of cells with EMF E1, E2, E3, E4 and internal resistance of each cell R1, R2, R3 and Rn. So there are n number of cells of EMF epsilon 1, epsilon 2, epsilon 2 up to epsilon n, and internal resistance R1, R2, R3 are connected in series. In series means what? The negative terminal of one cell is connected to positive terminal of another cell and so on. This is cell number 1 which has got a terminal potential of V1, and for this terminal potential V2 and terminal potential of this V3 and terminal potential of this is V4. It is the cells are connected between terminals A and B. First let us find out, since all the cells are connected in series and they have no reverse polarity, so we can say equivalent EMF. Equivalent EMF for all the cells in series is equal to first cell EMF of first cell, second cell, third cell plus up to nth cell. This is and R equivalent, since all are in series, R1 plus R2 plus R3 plus up to Rn. And what is the terminal potential difference? The terminal potential of cells, that is V1 is equal to EMF of the first cell minus current flowing in the circuit into internal resistance of the first cell, because current will come from positive to in the direction in the external circuit. Here also it will come this way, here also this come way. So this is the current I. And for cell V, for the cell 2, the terminal potential difference is its EMF minus I into R1. Since it is in series, current is same for everything. And V3 is equal to EMF of third cell minus I into R3 and V4, and so on. We come up to nth cell, that is terminal potential of nth cell is equal to terminal EMF of nth cell minus I into Rn. This is the terminal potential. We got it. What is the value of current? These series of cells are connected to an external resistance which is load. Say with this help of the cell, we are, say it may be a fan, we are deriving a fan, deriving current for the running the fan from these cells. So what is the total current? Total current is equal to EMF of the cell, total EMF of the cell, that is equivalent EMF divided by total resistance. See, this entire circuit can be represented with the equivalent circuit. This is equivalent circuit, terminal A and EMF and internal resistance in total with external resistance. This is the equivalent resistance of the above given circuit. This is the external circuit. This is E equivalent and this is R equivalent. What is the terminal potential? Terminal potential for this cell. Terminal potential is between these 2 points. That is terminal potential is V for the cell, where V for this cell, V is equal to equivalent EMF of all the cells, which is represented by this one, minus current flowing. This current will be flowing in this fashion, current flowing into R equivalent. This is the terminal potential of this terminal potential between. This is also equal to V is equal to current flowing through this into R. So this is R, and the terminal potential also can be represented. So I we have written. So what is the I equivalent? So I flowing through this EMF is equal to E equivalent is equal to this expression plus E3 plus E4 plus, and this is for N cell with unequal EMF and all sum of all the internal resistance. Or nth. So see, with this already we have seen it. In this circuit, all the resistance, internal resistance are in series, and all the EMFs are added together if there is no change in polarity of any one cell. So current is given, total net current is given by this expression, equivalent EMF is given for the series circuit, and R equivalent, internal resistance equivalent is given, and this also we can say terminal potential, because the same potential is available, the same potential difference is available between these 2 points, whatever is available between these 2 points. So also this VIR can be written as total current into external resistance. So this we can write it, this is I is equal to, I total resistance is equal to 1, 2, 3 all are in series, and this is also in series. So R plus, this is the expression for current through this series grouping of cells. Suppose if n identical cells are connected in series, because this is connected n identical cells, all the n identical cells, identical cell means all will have same EMF. E1 is equal to E2 is equal to E3 is equal to En, all will be equal to epsilon. That is, all are having same EMF and same internal resistance. R1 is equal to R2 is equal to R3 is equal to R, because all are this and this, everything is same. In this case, what is the terminal potential? Terminal potential EMF of one cell into current flowing through this one into R. This is V1. So V1 and V2. What about V2? V2 also same EMF minus I into R. Same way we can see VA, terminal potential of the nth cell also is equal to sigma into R, because all are having same EMF and all are having same internal resistance. Therefore V1 is equal to V2 is equal to Vn, because of all are having same, all the cells are having same EMF and same internal resistance. Now let us talk about this E equivalent, total net equivalent, that is E1 plus E2, because E1 is equal to E, epsilon 1 is equal to epsilon, and E plus and so on, plus nth up to n cells. So that is equivalent EMF is equal to n times of EMF of a single cell. What about this internal resistance? The internal resistance R equivalent is equal to R1 plus R2 plus R3 up to n. That is R1, because R1 also equal to R, R2 is equal to R. So we can write R plus R plus R plus R. So it's equal to n times of R, that is R equivalent is equal to n into R. So what is the current? Entire current is equal to total EMF equivalent EMF divided by total resistance. Total resistance means 1, 2, 3, 4 up to n, plus this is also in series, because all are in series, it gets added up. So I is equal to EMF equivalent is equal to n times of 1, n times of EMF of one cell divided by external resistance plus this is equal to EMF total resistance. What is total resistance? Total resistance of the circuit. Total resistance is equal to R plus R equivalent is equal to R, where R stands for the internal resistance of equivalent internal resistance of the series plus external resistance is equal to N into R. This is the total resistance. We can write R plus N into R. This is the expression for I, and this circuit can be equivalent circuit will be what will be the equivalent circuit? Equivalent circuit we can write it in this form. Total EMF, this is total EMF into internal resistance. So this is external resistance, that is epsilon naught equal, and this is R equivalent. R we can write this is equal to n times of EMF of one cell plus n times of internal resistance of n cell. This is the equivalent circuit. So I can be represented like this. The total current, this I can be, I is nothing but total EMF of equivalent plus total resistance